I am Buddhi Gunatilaka. I have done the send packet part in our Windows application. First, I will demonstrate what is our Windows application. First, it detect the interfaces in the Windows machine, and then it detect all the packets going through the network which we are connected, not only packets that come to our machine. And in the send packet class, I implemented that we can send packets to any service or any IP address. In this send packet class, first I have to open the interface by giving an interface device index number and index, and I have then I have created a TCP packet, and I can set the TCP packet IPv4 parameters. In that thing, I can add any source address or any destination address. By giving any source address and destination address, I can send fake packets to any destination address by setting source address as google.com or microsoft.com or any kind of address. By giving that as that kind of address, I can attack that service also, because I can send the packet with fake acknowledgement number. Then it will detect as that his acknowledgement, and it will create communication with me, and that's denial of service attack. With that send packets parameter setting part, we can do many things. We can do many kind of attacks in this thing, and we can set the data on the packet also, and that's my contribution.
I am Kosal Akshita.
In this project, my contribution for the project is to implement the main class. In here, I'm going to show details about the active devices and some packets that are sent from those devices. In here, I have first listed the all devices which are currently available, and then within this for loop, I am going to show some details about those devices such as name, description, and data link name, and MAC address, IP address, subnet mask, and broadcast address, like that. And in here we are going to snap some packets from a device which is specified in here, and this is the length of the maximum span. And using through here, we are going to capture each and every packet which are sent by this device to any other device. If you use false here, we are only going to capture packets which are sent from this device to our device. And here I am showing 100 packets which are sent by this specific device. If it is a null packet, we don't count it, and we will send the reply for that device, and the sending reply part will be demonstrated by my friend Buddhika. That was the contribution to this project, and thank you very much.
This is our demonstration. We have implemented a desktop application and an Android application. I contributed to the Android application. First, I will show you a demonstration of the Android application we built. So, this is the interface, and when you press start button, the details that takes some time. Details of packets are coming, and once you press stop, you can see information regarding packets, and this takes time. That's why this error message comes, and we will explain why this happens. Various information regarding packets are coming. So in the code, I will show what I implemented. This is the part I implemented. There is a Linux kernel command called TCP command, and we have used that in application. And an instance of a process is created, and that process executes this TCP dump command. So when it is executed, an input stream is created, and that is put into a buffer reader. And from that buffer reader, we are reading the information we need, that is information regarding packets which is given by TCP dump. So that's what I did. I'm Buddhi Prabha Arabatta.
Hi, I'm am Tarandu Ganapati. Now I will explain my contribution for the project. I did the Android root part, and it is essential for the project in capturing packets. Without that part, it is impossible to capture the packets. And I also implemented the network capturing part of the Windows application. It deals with the network interfaces and connects to them, and I also assisted in writing the report as well.
I am Visitha Baddegama, and I have done the packet printing part and hardware designing part. At first, after packets came from the TCP dump, by using printing thread class, I get all packets from input reader buffer, and by taking from that buffer by making a thread, and from I print all the information of packets in a text view. Then I print all the information of packet like source address, destination address, protocol, acknowledgement number, and sequence number. Here we can find all the packet details. This is the time, and next this is the source IP address and destination IP address. Next, this is acknowledgement number, and this is the port number. So by using this information, we can filter each and every packet and take desired security requirements. This is my printing thread method. By making a thread from this method, from this class, we can get all the packets from this TCP dump. As the hardware design we discussed, there's a signal filter module. That module takes all the signals that came from and forwards them to the demodulator. Since all the signals are modulated, this demodulator module demodulate all the signals and converts them to the analog to digital converter. After conversion part has been done, the analog to digital converter module forwards these signals to decoder, and that decoder forwards all the signals to frame identifier. This frame identifier module will identify all the packets, and it will divide each and every packet. Then we can identify each and every packet that came from with the signal, and we can do error detection after that. After the error detection, there may be several modules to give security requirements to our application. There may be several modules like authentication users, check file types, check file sizes, and check protocols, and check for spams. Likewise, there may be several sub-modules to give security requirements to our application. After done these security requirements, we can send each and every packet to our computer.